Hey guys, welcome back to Taylor series. I hope everybody had an opportunity to watch some of my videos on Taylor series. You definitely don't need it to understand how to do this problem, but I think that if you watch them all in a row, everything will make sense. So subscribe to my channel, leave a comment, and so on. All right, let's get right to it. This is an interesting problem. They gave it back in 2008. I just think that everybody should know how to cover all types of Taylor series. So it says, let's see. Let h be a function having derivatives of all orders for x greater than 0, and selected values of h and its first four derivatives are indicated in the table above. That's those guys. The function h and these four derivatives are increasing on the interval 1 to 3. So the first problem says, write the first degree Taylor polynomial for h about x equals 2. So we're centered right there. Okay, so let's do that. It wants a first degree. That means it just wants it to the first power. And what I did was I went back to my old video and I actually just wanted to show you that we're just trying to keep everything consistent. I took this from my old videos because that's how we write a Taylor series. And I basically just need first degree. So that's just up to there. All right, so P1 of x, that's indicating that I'm only going to do first degree, okay? I'm going to take, because I'm using about x equals 2, I go right there. This guy here is 80, okay? The next one, I need the derivative, which is this guy right here. That's 128. And then x minus c, since it's about x equals 2, that's how I do that. And then you guys are done. How simple. Now we're going to use it to approximate h of 1.9. All right, so p of 1.9. I did this already in the calculator. You just plug in your 1.9, and this problem, you're allowed to use a calculator. You get 67.2. So it says, use it to approximate 1.9, and is this approximation greater than or less than? Well, is it going to be greater than or less than the actual? It's going to be less than, guys, and I'll tell you why in a second. It's going to be less than because over here they told you everything is increasing. So let me see where I can write this. I'll write it in red so I can show you. The first derivative increasing means the slope would be positive this way. When the second derivative is increasing or positive, it means it's going to be concaved up. Now, remember that this really is an equation of a line, right, guys? This is an equation of the line. If you try to map this equation of the line tangent to this, whatever this function is, it's going to be below it. So if, let's say, this is h1.9, then this is h1.9. But basically all you have to say is that since h prime is increasing on the interval, then it's less than. So I hope that makes sense, all right? So since it's increasing, the approximation will be less than. All right, now I'm going to get rid of just some of this stuff here because we're going to need it for the next part. You guys can always pause the video and take your time understanding it. The next part says write a third degree. So right now we used him and him. Third degree Taylor polynomial for h about x equals 2. All right, so I need the next guy here. 488 over 3 x minus 2, that's to the second power. Okay, and then finally I have 448 over 3 times x minus 2 to the third power. All right, now for some strange reason I believe that this guy in the original problem was a 6, so I apologize because I have the problem from the scoring guide, so they might have made an error, but it's either 3 or 6. You guys will have to double check that. Okay, anyway, you go and use it for h to approximate h 1.9. So all you got to do is put 1.9 in here, and then you put 1.9 for every x, and you get 67.988. And so that is how you construct Taylor polynomial for first degree and third degree. So I hope that was helpful, and come back for another video.